First one, 10 lamps connected in series across the power supply. The voltage across each lamp is 6 volts. What is the voltage of the supply? So in series, voltage adds up. So it would be 6 times 10. So 6 volts across each of the 10 bulbs. If each bulb has 6 volts, it would be 10 times 6, 60 volts for question 1. Question 2, 10 lamps connected in parallel across a 12 volt supply. What is the voltage across each lamp? In parallel, the voltage is the same in every branch. So each lamp will have 12 volts across it as well. Right, question 3. This is where it gets a bit more complicated and a bit more interesting as well. See if I can scroll down. There we go. So ammeter there reads 1 amp. All resistors have the same value. What is the current through the black resistor? So if you have current coming along here, so remember current goes from positive from this long line of the cell round to the short line, so from positive to negative, comes around here and then divides. So some of the current goes through this top branch, some goes through the bottom branch. There's 3 times as much resistance in the bottom branch here as there is up here. So that means you're going to get a third of the current. So if you've got 1 amp through there, you're going to have 3 times as much current in this top branch, so it'd be 3 amps up here. So it must be a total current of 4 amps coming along here, then splitting. So 4 amps coming into this junction, 3 amps at the top, 1 amp at the bottom. Current doesn't get used up, it recombines here, so then it gets back to 4 amps. And here you've got identical resistors, so that current's going to split into 2. You'll have 2 amps going through the top and 2 amps going through the bottom. So the answer for this one will be 2 amps. Question 4. 6 as well. Question 4. So we've got 8 ammeters here. Ammeter 5 reads 3 amps. All the resistors are 10 ohms. What are the readings on ammeters A1 to A8? And what's the voltage of the battery? So whatever values we get for A1, A8 and A7, they will all be the same number. But we start with A5 here, so 3 amps. A5 has twice the resistance of this branch here. So A2 will be twice the current of this branch here. So A2 will be 2 lots of A5. So if A5 is 3, A2 will be 6. And then this middle branch here has 3 times the resistance of this top branch, so it will have a third of the current. So if A2 is 6, A3 and 4 will be a third of 6, which is 2. So it will be 6 amps, 2 amps, 3 amps. A6 will be whatever A5 is added to A4. So A5 is 3, A4 was 2, so 3 plus 2 is 5, so A6 will be 5 amps, and A7 will be A6 plus A2. A2 was 6 amps, I think we said, so 5 plus 6 is 11, so A7, A8 and A1 will all be 11 amps. Check right. Yeah, so the answers are so you've and then the voltage, there's different ways you can do this. You could work out the combination of that total resistance. Don't need to though, because in parallel circuits the voltage is the same in each branch, so the voltage of the cell will be the same as the voltage across this top branch, which would be the same as the voltage across the middle branch, which would be the same as the voltage across the bottom branch. So in this branch here, we know that A2 is 6 amps, the resistance is 10 ohms, V equals I times R, so V equals 6 times 10, it'd be 60 volts, so I think the terminal voltage should be 60 volts. And they don't give an answer for that, but you just get my word for that, 60 volts. Right, question 5, this looks like a complicated one. So R has a voltage of 24 volts. What is the voltage across the upper 10 ohm resistor? Right, so this voltage here across the 10 ohm resistor will be the same as the voltage across these 2 resistors, because voltages in parallel branches is the same. If that's 24 volts, then the voltage across that whole section, which will be the same as the voltage across that bit, and the voltage across that bit will be 40 take away 24, which is 16. So A will be 16 volts. Yes. Current through the upper 10 ohm resistor. So it's 16 volts, 10 ohms, V equals I times R, I equals V over R. So it would be 16 divided by 10, 1.6 amps. If I zoom out a little bit, I think we could probably be able to see the answers and the questions on the same screen. Get rid of this bit as well. Get rid of that. That's the one. There we go. Voltage across the lower part of the parallel circuit, that'll be 16 volts as well, because voltages in parallel branches are the same. Reading on A2, so you've got 16 volts across 40 ohms. So it'll be 16 divided by 40. I've got a calculator here, you can probably hear the buttons. 16 divided by 40, 0.4 amps. 0.4, yes. The readings on ammeters A1 and A3. So A1 and A3 will be the same. If we know the current here was 1.6, and we know the current here was 0.4, so A1 is dividing up into those two currents. So A1 must be 1.6 plus 0.4, which gives you the 2 amps. And the value of R, it's going to be 2 amps going through it. It's got 24 volts across it, so resistance is voltage divided by current, so it'll be 24 divided by 2. I'm doing a calculator, I don't need to. I can do 24 divided by 2 in my head, 12 ohms, and I can see the answer to 12 as well. So those are the answers. Make sure you make corrections. Have another look through this if it doesn't make sense, and we'll get some more work done on this and some more of the electricity stuff in the next few lessons.